Hi everyone. We are solving systems of equations by graphing. So we are going into systems of equations, the unit now. You might be kind of glad to get out of those transformations for a little bit, but we have different ways that we're going to solve systems, and the first way we learn is graphing. But first of all, let's write down the definition of a system of equations. And that is two or more equations with the same variables. That's what a system of equations is. To solve a system with two variables, find the ordered pair that satisfies all of the equations. When we are graphing, so we're going to graph both lines here. These are linear equations. When we are graphing, we're going to look for the point of intersection. That ordered pair that is the point of intersection should be the solution. So I've got example one here. I've got two equations, two linear equations. I'm going to graph both equations and write down the solution. I'm going to tell you something here, and I think I've set up most of the systems like this, but this is in slope-intercept form. This is kind of in standard form, ax plus by equals c form. When I have it in slope-intercept form, I'm going to use the slope and the y-intercept and graph from that. When I have it in this form, the standard form here, I'm going to use the intercept method. If you remember those table with the zeros, but that'll remind you. Now I apologize for not having graph paper handy for you. If you have a sheet of graph paper, by all means, go ahead and do it. But we are solving by graphing, so we do have to be careful. So I'm going to try to take extra care when I do that. So I'm making my x-axis and my y-axis, and I want to keep these pretty evenly spaced out. I don't want big variations in the tick marks that we're making here. Wasn't quite able to get that part of it done as far as the graphs and stuff and have those for you, so we're just going to have to write them out by hand today. So I'm going to graph the first equation, y equals negative 5/3 x plus 3. Now the y-intercept, b, is 3, and m, the slope, which I'm going to use for rise over run, is negative 5/3. And that's the rise over the run. This is the y-intercept. So that's the first place. B means begin here. Begin here. 3 on the y-axis. That is a point on this line. And then I'm going to go down 5. 1, 2, 3, 4, 5. And over 1, 2, 3, and draw another point. And I'm trying to be careful, so I'm going to do it one more time. I'm going to go down 1, 2, 3, 4. Wendy, I lost my count. 1, 2, 3, 4, 5. So that's kind of down there. Let me just lower that point a little bit. 1, 2, 3, 4, 5 over 1, 2, 3. Once again. All right, and I'm going to try to be real careful because we are looking for the point of intersection when we want this solved. Okay, so there's the first line. I have graphed this line. This line is, this equation is in standard form. X minus 3y equals 9. I'm wondering if you recall when we set up our zero table, put 0 in for x, and put 0 in for y. When x is 0, we've got negative 3y equals 9. And when we divide by negative 3, y is negative 3. When y is 0, we've got x equals, that's 0, the x equals 9. So I'm going to plot 0, negative 3, 1, 2, 3. That's the y-intercept. And I'm going to plot 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And it looks to me like if I go up 3 and over 3, I'm sorry, up 2 and over 3, it looks to me like we might be going through that point right there. Let's see, I'm going up 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I go up 1, I'll go over 1, 2, 3. So yeah, I am going through that point. All right. We happen to see the point that it's going through, which the x-coordinate is 1, 2, 3. And the y-coordinate is -1, -2. 3, -2. So when I write the solution for this, I'll write x, y equals 3, -2. Now what I want to do real quick is check it. If I take -5/3 times 3, -5/3 times 3, the 3's cancel out, and then I add 3, I get -5 plus 3, which is -2, which matches this. The -2 for the y and the 3. And then if I put 3 in for x, minus 3 times -2 in for y, does that equal 9? -3 times -2 is +6, and 3 plus 6 is equal to 9. So this is the solution. It works. This is the solution. If I was off the page, it works for both. Sorry. Works for both equations there. All right. The next example. Example 2 here. I've got 4x plus 2y equals 6, and y equals -2x plus 3. Oh, let's just go back. In this case, the system, when we graphed, we had intersecting lines and that one ordered pair and one solution. We found the ordered pair that works in both these equations by graphing and getting that solution. All right, example 2 here. Again, I apologize. For no graphs for you. All right, 4x plus 2y equals 6. I'm going to make my 0 table. The intercept table is basically what it is. When x is 0, 2y equals 6. And when I divide by 2, 6 divided by 2 is 3. When y is 0, I've got 4x equals 6, and when I divide by 4, I take 6 divided by 4. I think if you work that out, 6 divided by 4 is 1.5. Okay, so we're dealing with halves. That might get kind of tricky, but let's see. Let's see if we're up to it. Here's 0, 3. Here's 1.50. I'm going to draw my line like so and try to keep it nice and straight. Again, we've got to be careful when we're graphing. If we're using graphing to solve the problem, we've got to draw good graphs. Now, y equals -2x plus 3 is in slope-intercept form. My slope is -2 over 1. I'll just put it over 1 for the rise over the run. And I got to have a place to start before I start doing this, and that's the b value, which is 3. Oh, dear. Okay. That is the same thing. So I'm going to go down 2, and over 1. It looks like I'm right on that line. If I go down 2 again and over 1, every time I do this, I'm hitting the line. Okay, so what we have here is every single point. This works, this point works, this point solves both, this one. Every point on the line, we have two equations. Write this down. Two equations for the same line. Okay? If that happens, you have infinite solutions. Doesn't mean everything is a solution. You just can't count the number of solutions. That's what it means. Okay, hope that was on the screen. I'm having a hard time. It's sunny out here, and the screen I'm looking at is pretty dark because of the sun shining on it. But, so that's different than this one. This one I had intersecting lines. I did have one solution. This one, when I graphed the first line, I had it. And then when I went to graph this line, it landed right on top of that line. So it's two equations for the same line. And in that case, we have infinite solutions. All right. I got one more example for you before I get you practicing on your own. Okay. Trying to keep those, looking at the gaps a little big, but that's all right. All right, the first one is in slope-intercept form, y equals negative 2/3 x minus 6. The slope is negative 2 over 3. I'll use that for rise over run. And the y-intercept b is negative 6. So I'm going to graph that line. 1, 2, 3, 4, 5, 6. Begin at negative 6. Now let's go down 2 and write 1, 2, 3. I'm going to go up 2 now. Up 1, up 2, and left 1, 2, 3. Let me go up another 2. 1, 2, oops, over 1, 2, 3. I think if I do that one more time, I'll be on the axis. 1, 2, 1, 2, 3. Yeah, I am. Okay. So I'm going to draw this line very carefully, kind of straight. All right. Now it's time for the second equation. 2x plus 3y equals 6. And I'm using my intercepts this time. When it's in the standard form, I just going to do that. When x is 0, I got 3y equals 6. And then I've divided by 3, and y is 2. When y is 0, I got 2x equals 6. And I've divided by 2, and x is 3. So let me plot 0, 2. 1, 2. Let me plot 1, 2, 3. 3, 0. And let me draw that line, and I'm looking to see where they cross. And I think there is a problem here. Looks to me like we have parallel lines. Parallel lines never cross, and that means there is no solution. So what you see are the three scenarios in a system. Graphically, you may have parallel lines when you graph both the equations, and then there's just no solution. Remember the second scenario here. Let me see. When we graphed both equations and ended up on the same line and had infinite solutions. And then maybe the most common thing to happen is the lines will intersect and you have one solution that you've got to find.